What is going on, Alex Bros? In this video, we're going to do an application involving the three different types of symmetries a graph can have. Let's dive right into it. We're first going to plot the ordered pair negative 2, 3. So I'll do that in each one of these coordinate planes. And there are three different things that we want to do. We want to plot the point that is symmetric to this point that we just plotted in each of these planes with respect to the x-axis is the first part, the y-axis is the second part, and then the origin. Let's start with the x-axis. So for this, you want to keep in mind that if a graph has symmetry with respect to the x-axis, this axis here, there's going to be a corresponding point across from the one that we plotted with respect to the x-axis. One way to obtain that point is to remember that any y-coordinate provided to you off the bat can be converted to its opposite to get the new y-coordinate of the point that corresponds to, in this case, negative 2, 3. So in other words, negative 2, 3, upon changing the y-coordinate to its opposite, will generate negative 2, negative 3. And if we plot that point, negative 2, negative 3, we could see that they're the same distance away from the x-axis, each of the 2 points, and they're corresponding. If we were to cut this out and fold along the x-axis, the 2 points should overlap with each other. And so that would be our answer to part A. For part B, we want symmetry with respect to the y-axis. And to construct the ordered pair for our answer, we're going to change the x-coordinate that's provided to us to its opposite. So negative 2, 3 will generate positive 2, 3. And if we plot that point, we could see that the points are mirror images of each other. In other words, if we were to cut out this coordinate plane and fold it along the y-axis, the points would overlap. And so that's how we know the point 2, 3 is symmetric with respect to the y-axis in relation to negative 2, 3. Now for the origin, we want to turn both coordinates into their opposites. So negative 2, 3 correspond to positive 2, negative 3. And if we plot that point, we end up with a point that's in quadrant 4. And how would we know that they are symmetric with respect to the origin? Well, if you were to connect these 2 points with a dashed line segment, you should pass through the origin, which is the dead center of the coordinate plane. And that would be our answer to part C. Alright, and that's where all the fun for this video ends. If you guys have any questions, you know how to reach me. Otherwise, I'll see you in the next one. Thanks for watching.